superposition of two perpendicular harmonic oscillations. Now let us consider two harmonic oscillations represented by x is equal to a sine omega t plus phi and y is equal to b sine omega t. So A is the amplitude of harmonic oscillation represented by x, that B represented by y, and the frequency are same, omega. Phi is the phase difference between the two waves. So suppose x is propagating in this direction and y is propagating in this direction. So this angle is 90 degree. That is, the angle between the two waves is 90 degree, but having phase difference phi. From here we'll have y by b is equal to sine omega t. Now here we'll have x by a is equal to sine omega t plus phi. Then you expand sine omega t cos phi plus cos omega t sine phi. Okay. Now what is sine omega t? Sine omega t is equal to y by b. You put the value y by b cos phi plus what is cos omega t? 1 minus sine square omega t into sine phi. Next y by b cos phi plus what is sine omega t? Sine omega t y square by b square sine phi. Next implies x by a minus y by b cos phi is equal to under root 1 minus y square by b square sine phi. Now squaring both sides, we have x by a minus y by b cos phi is equal to whole square is equal to under root 1 minus y square by b square sine phi whole square. Next this is x square a square, this is y square b square cos square phi minus twice xy ab cos phi is equal to here 1 minus y square by b square, okay, sine square phi, and this implies x square by a square plus y square by b square cos square phi bracket. Here this is sine square phi and minus y square b square sine square phi. So you take common y square b square, this is your sine square phi minus twice xy ab cos phi. Here only the term sine square phi will remain. Okay. Next x square by a square plus y square by b square. Why? Because sine square phi plus cos square phi is equal to 1 minus twice xy ab cos phi is equal to sine square phi. So this is the equation. Suppose this is the equation 1, and equation 1 represents the equation of an ellipse in general, and as shown in figure below. So this length is twice a, this length is twice b. This is an ellipse. So this is our x-axis, this is y-axis. So this implies our semi-axis, this is called semi-major axis, and this implies our semi axis, this is semi minor axis. So equation 1 represents the equation of an ellipse which may be drawn like this. So this implies an ellipse. Now special cases. Number 1, let phi is equal to 0. Therefore, what is cos 0 is equal to 1 and sin 0 is equal to 0. So 1 implies what? X square plus a square, y square plus b square minus twice xy ab cos 0 1, and that is equal to 0, sin 0 0. So this implies what? This implies x by a minus y by b whole square is equal to 0, and this implies x by a minus y by b is equal to 0. Again, this implies y by b is equal to x by a. Again, it will give what is y? Y is equal to b by a x. And this is the equation number 2. This is the equation of a straight line, so passing through the origin as shown in figure below. So this represents a pair of coincident straight lines passing through the origin. Here this is your twice a and this is twice b, okay, and this is our a and this length is our b. What is tan theta here? Tan theta is equal to definitely b by a. What is theta? Equal to tan inverse b by a. So this is the angle made by the straight line with x axis. So equation 2 represents the equation of a pair of straight lines passing through the origin and making an angle theta given by theta is equal to tan inverse b by a with x axis. Next special case 2. Let phi is equal to pi. So what is cos pi? You know, that is minus 1, and what is sin pi? That is equal to 0. So equation 1 will immediately give you x square by a square plus y square by b square minus twice xy ab into minus 1 is equal to 0, and this will give you x square by a square plus y square by b square minus twice xy ab is equal to 0. ab is equal to 0, and this is equal to x by a this will be plus, minus 1 is plus, x by a plus y by b whole square is equal to 0, and this will give you x by a plus y by b is equal to 0. This will again give you y is equal to minus b by a x. So this is our equation number 3. This equation again represents the equation of the pair of straight lines passing through the origin as shown in the figure below. Here you see the O origin. This is the equation of the straight line which passes through the origin, and theta is the angle made by the line with our x-axis. Now this is, if this is origin, so towards it this is minus b, and this is your plus a. What is tan theta from here? Tan theta is equal to minus b divided by plus a. So what is theta? Theta is equal to tan inverse minus b by a. So this is the angle made by the line with the x-axis. Next case 3, let the phase difference between the two waves is 90 degrees. So you know cos 90 degree is equal to 0 and sin 90 degree is equal to 1. Therefore this will give 1 equal to x square plus a square y square by b square minus twice xy ab cos 90 degree 0 is equal to sin 90 degree 1. So this will give you x square by a square plus y square by b square is equal to 1. Again, this is our equation number 4. This equation represents the equation of an ellipse. Represents the equation of an ellipse having semi-major axis A and semi-minor axis B, as shown in figure below. You see here, this is our semi-major axis A and this is our semi-minor axis B. So this represents the equation 4. So this is the equation of the ellipse where A is the semi-major axis, B is the semi-minor axis. Now let A is equal to B. Then equation 4 will reduces to x square by a square plus y square by b a square is equal to 1, and this will give you x square plus y square is equal to a square. Where equation, this is our equation number 5. Equation 5 represents the equation of a circle where a is the radius of the circle. Next, for situation let phi is equal to pi by 4. Then we have cos pi by 4 is equal to sin pi by 4 is equal to 1 by 2. Then equation 1 will give you x square by a square plus y square by b square minus twice xy ab, and this is a cos phi is equal to 1 by root 2 is equal to sin square by 1 by root 2 whole square, and this will give you x square by a square plus y square by b square minus this is root 2, so there will be root 2 xy ab is equal to 1 by 2. So this represents the equation of an oblique ellipse. Okay, oblique ellipse. Okay, thank you. Next.